Birds have body temperature 39 to 43 C. Does that mean that when virus, bacteria jump from birds to humans, our fever is ineffective in fighting it? Good question, but a fever is not only heating the body to kill the pathogen. Body heat helps with the multiplication differentiation of immune cells. In short, the heat doesn't kill the pathogen. The immune system kills the pathogen and needs some extra heat to work more efficiently. Edit. Made a small mistake in remembering and translating. In my memory it was division, but it should have been differentiation. This is an important difference, but the last sentence is correct. Source link. As you can imagine, it's more complicated than that. For one thing, temperature effects go both ways. Viruses replicate worse at lower than optimal temperatures, as well as higher. That means that the relatively low temperature of humans makes it harder for avian viruses to infect them. It's likely that one side effect of that is that avian influenza viruses don't replicate well in the nose and throat, where temperatures are lower. They prefer to replicate in human lungs, where temperatures are higher. That in turn probably means that avian viruses don't transmit as well, because they're not making virus where it can easily be shed, but also might mean that the disease they cause can be more severe. But on the other hand, very typically these viruses will rapidly pick up mutations that adapt to the lower temperature of mammals. For example, the most often observed and well-described mutation codes for a lysine instead of a glutamate at position 627 of the PB2 protein, PB2E627K, and is solely sufficient for replication of several avian influenza viruses in mammals. It has been shown to increase transmissibility of avian viruses between mammals. 118. Presumably due to increased polymerase activity at lower temperatures, as found in the human upper respiratory tract, 33 to 35 degrees Celsius, compared to the avian intestinal tract, 38 to 40 degrees Celsius. Adaptation of avian influenza A virus polymerase in mammals to overcome the host species barrier. I don't think anyone has asked specifically if these mutations make the virus less tolerant to fevers. My guess is that it would, but there are too many variables, especially the location of infection, and also whether fever actually does much against non-opportunistic pathogens anyway, to make a confident statement. So it's hard to generalize, because you're dealing with moving targets.